So let's take a pause for a minute. Let's recap what we have learned. We have a charge. Charge will alter the space around it. That is, any other charge coming into this space will experience a force. It can be either a push or a pull. And this is because of the fact that there are two kind of charges, positive and negative charge. Now, study of this forces, we do that with the help of something called as electrical field. Right? And electrical field talks about what happens with a unit charge, positive unit charge. Now, we moved on to the concept of electrical potential energy or electrical potential. Actually, we started off with that. So, electrical potential is to do with study of the electrical field in a scalar manner. So, electrical potential at a point, say A, is nothing but work done in carrying a unit charge from infinity to that point. All the work, the entire work, will be equal to its potential energy at that point. Now, what if we are not, we don't deal with all the time with a unit charge. Of course, in nature, in real life, we are not just looking at 1 coulomb of charge, we are looking at q coulomb of charge. It can be more than 1, it can be less than 1. Is it not? So we are not just moving around with 1 coulomb of charge like this. We can have a lot more charge or a lot less charge or even negative charges, which is non-1 in magnitude. So we need to deal with them as well. And that topic is your electrical potential energy. Okay guys, electrical potential energy has to do with non 1 coulomb of charge. Right? So this pretty much summarizes what we are trying to do. From 1 we are moving on to q. Q can be greater than 1 or lesser than 1. Okay. A charge in electrical field will move or not move? Yes, it will move and has energy. Because it moves, it has energy. The change in an electrical field, a charge in an electrical field has potential to do work. Right? Let me put it in this way. A charge in an electrical field will get to move. If we just leave it, it will get to move. So it has energy. So it has the capacity to do work. It has the potential to do work. And this energy is your electrical potential energy. Does it make sense? Right? Now, next thing. As a definition, what is it? The work done by an external force in bringing a charge, not just unit charge, from infinity to a specific point in the field without field, just a second, field with almost no acceleration, right? To a specific point in field with almost no acceleration. That is, we are moving very slowly. So this is how our derivation starts. That's how we can equate our force of external force being equated to the force by the electrical field. To do that, we make use of this particular assumption. A small note. Electrical force are, we have already seen this. Electrical forces are, yes, they are conservative forces. And so the entire work, what happens to the entire work? They get, stored as potential energy of the two charges. Right? Again, all these are commonsensical. We have seen this from past 3-4 years with different topics. So the same funda over here. So just an introduction. Please do write the definitions and everything. If you guys want to write this.